Line and circle in polar coordinates. In polar coordinate, the equation r equals r0 represent the circle, center at the origin or the pole with radius r equals r0. Notice that in this equation, the angular theta is missing. That means the angle can be anything, any angle, but the distance from the origin to the point has to be r0. And by definition, the set of point that has the same distance from a fixed point is a circle. Similarly, the equation theta equals theta naught represent a line that goes through the origin that's specified by the angle theta naught. Observe that points on circle have different angle with the positive horizontal axis, but the distance from such point to the pole is constant, equidistance. This set of point that is equidistant to the center is a circle. With any two distinct points on the line, their distances from the point to the pole are not the same, but the line that goes through the origin and that point form an angle theta naught with a positive horizontal axis regardless where the point is on the line. We can also obtain the line in polar coordinates not passing the origin. The line L whose point P0 equals d, alpha closest to the origin is r equals d secant of theta minus alpha, where d is the distance from the point P0 to the origin and alpha is the angle formed by O P0 and the positive horizontal axis. In this case, by closest to the origin P0, we mean the line O P0 should be perpendicular to the line L. This angle is alpha and the distance O P0 is d. If P is any arbitrary point on the line L with the coordinate r, theta, the radial coordinate is r and the angular coordinate is theta measured from the positive horizontal axis, then using this right triangle, we have cosine of theta minus alpha, which is the angle inside the triangle, equals adjacent, which is d over the hypotenuse r, d over r. If we isolate r, we have d over cosine of theta minus alpha, which is the equation of the line L whose point P0 d, alpha closest to the origin. R equals d secant theta minus alpha.